Okay, so today we'll finish up law of sines. Okay, so same section. We're just going to focus on that third case that could have the two solutions or no solution. Okay, so just as a reminder, that's the law of sines. Okay, so if you have that in your notes from yesterday, you don't need to write it again. But we went through and we showed the first two parts, okay, kind of where they come from. And then the third part, we just kind of looked at the pattern and wrote down what we thought was the third part, and that's what it actually is. Okay. So just to kind of recap, if you've got law of sines, can somebody remind me, what are the three types we have under law of sines? Jamel? All right, so we've got side angle. I'm going to put that one there and put an asterisk because that's the one out of all of them you've got to be careful. Yep?
Angle side angle.
So angle side angle, always one solution. Yep?
Angle side.
And angle side. Or side angle, that's the same thing. So those are the three kind of problems you use law of sines for. Tomorrow, we'll write down the two that use law of cosines. Okay. All right, so as far as notes, there's really nothing else we need to know. We're going to do the same kind of problems we did yesterday. Right? Except we're going to focus first on the problems that could have a no solution, two solution, or one solution. If we have time, I think in the word problem, we might review one of these other ones. Okay? But that'll be at the end. Okay, so we'll start by looking at that table. Anybody tell me again why this is law of sines, just by looking at the table? You could make a sketch, but you could save time just by looking at the table. We have a complete row. Now, there's also something here that tells me this is the case that could have the no solution or the two solution. I have a completely empty row, and it's impossible to find anything in it. Okay? It's not like the problem we did in the homework where you had two of the angles and you could just add them up and subtract from 180 to get the third one. Okay? You can't do that. And you can't do Pythagorean theorem to get C. Why can't we do Pythagorean theorem? Yeah, if you do Pythagorean theorem, you're assuming you already know this is 90. We don't know that. Okay? So we have no way to find anything in this last row. So what are you forced to find first? Beta. You have to do beta first. Okay? And then I usually make the box big enough so that if there's two answers, I can write one in the top and then one in the bottom. I would make your box big enough this time. Just a suggestion. All right, so let's set up law of sines. Okay, so we're going to find beta. Marcos, what row am I going to use to find beta? I'm going to use this row a lot. Yeah, I got to use the first one because it's the only row that has everything in it. Okay, so can you set that up, Marcos, in the left side using the row 1?
Sine 35 over 6.
Yep, perfect. Sine 35 over 6. And then on the other side, we have to use row 2. If you use row 3, you'd have two letters. And I said you can only have one letter in the whole problem. Okay, so we got to use row 2. Yeah. Yeah.
Yeah, sine of beta over e.
Oh, yeah, sine beta over e. Okay, so we solve it just like it's a regular problem. You're going to cross multiply. And actually, this time, you really don't even need to cross multiply. Just multiply each side by 8. That cancels that. And that automatically gets sine beta by itself. So we have 8 sine 35 over 6 equals the sine of beta. But remember, we just want beta. So what do we do to get rid of sine? Yep, we do inverse sine. So if you take the inverse sine of what's on the right, it's going to cancel regular sine and do the same thing on the left. Okay, so we'll type that in. And if we get an error, it either means you typed it in wrong or it's a no solution problem. If you type it in and get a number on the screen, then that guarantees us there's at least one solution. And then we have to check for the second one.
That doesn't cancel out the sign of the other side?
No, because there's extra stuff with it. The only thing you could reduce is you could make this a 4 and you could make that a 3 if you wanted, but you're just going to type it into the calculator, so it doesn't really matter. But you can reduce 8 and 6 by 2. Honestly, I wouldn't even bother doing that. Okay, first thing I should do before I even start typing anything in. Yeah, Devin?
Change the degrees?
Yeah, we're using degrees this week, so make sure you're in degrees. Don't make the mistake of putting it in radians and then everything comes out wrong. All right, so we got degrees. Okay, we've got inverse sine, and again, nothing cancels out. You've got to type it in exactly the way you see it, unless you reduce the 8 and the 6. But. So we've got 4 sine 35. What should I do next? Yep. Yep. If you don't close it, it's gonna mess up. Divided by 3. So I get 49.886. So this is not a no solution. I just got a solution. 49.886. Now, does anybody remember what you do with that number to find the second solution? Now, even once we do that, it doesn't guarantee it works. We still have to check it. Yep. Yeah, subtract that from 180. So 180 minus 49.886 gives me 130.114. Okay, so if there's a second solution, that's what it is. How do I check if that second solution works? What do I have to look for? Well, think about, what about the angles in a triangle? What do we know about them? Right? So what do we know about all the angles in a triangle? They all have to add up to a maximum, they have to add up to 180. So could you fit a 130-degree angle in the triangle that we have? Think about, what were we given? Yeah, Miles? We were given a 35, and we're asking if you could fit the second answer with a 35. Yes, because if you add 130 and 35, it's only 165. So the second answer works. Okay, so we need to write that 130 down as another answer. And what I'll do, just to make them different, is I'll call it beta 1. And the second one, I'll call beta 2. So any question on how we found the second answer or how we determined that it's going to work this time? Because that's going to change how we do the rest of the problem now. So we looked at the angle that was given, and we looked at the angle that we think would be the second answer, and if you add them together, they could fit in the same triangle. It's less than 180.
Oh, okay.
If the second answer came out to like 170, then it wouldn't fit with a 35. It'd be too big. Okay, so since we have two answers for beta, what else does that mean? Yep.
We're going to have two answers for gamma.
Yep, we're going to have two answers for gamma. And we're going to have two answers for C. Okay, so it's really like we're doing two problems now. Okay, it's not harder, it's just we have to do everything twice. Okay, let me circle everything that's in one of the problems we're solving. Let me get rid of this so it's not confusing. That angle is in one of our triangles. So is that angle. And so is that angle. Those three angles in blue make up one of the problems. And the three angles in green make up the other problem. So alpha is in both. Okay, that 35 is in both. And then beta 1 and gamma 1. And then alpha, beta 2, and gamma 2 is your second triangle. So Dave, how would I get gamma 1?
Oh,
All right, which, when you say both of them, which ones? Alpha and beta 1. So I add alpha and beta 1, and I'll subtract that from 180. And that means gamma 1 is 95.114. Okay, and Wendy, how would I do gamma 2?
You add 35 and
35 and 130. And then
subtract it from 180.
subtract that from 180. And I get 14.86. Okay, so now we have all of our angles. The last thing we have to find is C1 and C2. Which row am I going to use to find C1, and I'm going to use it again to find C2? Yeah.
The first row?
Yeah. We're going to use the first row because it was given, and we know it's correct. And it's in both triangles. Okay? If you want to circle the sides that represent the triangles, we have this side, those are in both. And that side. So everything in green, that's one triangle. And everything in blue, that's my second triangle. So I have six things in blue, 6 things in green. And some of them are shared. All right, so let's set it up, let's find C1 first. So find C1. So we got sine of 35 over 6. And Brianna, what angle am I going to use to find C1? I'm going to use gamma 1 or gamma 2?
Gamma 1.
Yeah, we're going to use gamma 1 to find C1. You're going to use gamma 2 to find C2. So we're going to put sine of 95.114 over C1. Okay, so Riley, when you cross multiply, what are you going to get for C1? What times what divided by what?
Sine 35 over C1. Sine 95.14 over 6.
So you remember, you're going to cross multiply, right?
Yep.
So once you cross multiply, you're not going to have any fraction until you solve for C1. So if we get C1 by itself, after you cross multiply, well, do you know what you would get? Not sure. Sydney, can you help them out? What did you get there?
6 sine 95.114.
Yeah.
Versus 934.
So you got 6 sine 95. And that would equal C1 sine 35, but then you're going to have to divide by sine 35. Okay. So we'll type that in a second, or if somebody can type that in, we'll do C2 now. But we'll come back and type that in. Okay, so now we'll find C2. You're going to set it up pretty much exactly the same, except you're just going to change the right-hand side. Left-hand side is going to stay the same.
Does it matter if you put sine 35 over 6 sine, like if you flip over?
You can't flip this final answer.
Okay.
If you had the original problem and you flip those two and those two, you'd still get the same thing. But you have to get exactly what we wrote for C1. Okay, so we'll set it up for C2. So we've got sine 35 over 6 equals, and now use gamma 2, sine of 14.86 over C2. 6 over C2. Okay, so when we cross multiply and then get C2 by itself, Graham, what will I get for that?
Six sine
sine 35. Okay, so again, just type that in and write down what you get. Hey, does anybody have the first one?
1.469.
1.469
Yes.
for C1? I'm going to write that off to the side for a second. And what did you get for C2? Or are we still typing in C2? Okay, well, while people are typing in C2, let's look at what we got for C1. Why did I write it off to the side? I don't even have a calculator, so I can't check if he did it right, but I can check if he did it wrong. I can check that. Yeah?
Because it's smaller than the other sides and with the biggest angle.
Yeah, I'm looking at it and I'm thinking this is the biggest angle out of everything circled in blue. So this number has to be bigger than 6. Or actually, no, it has to be bigger than 8. But actually, I wasn't even thinking of that. I was thinking when you add two sides together, it has to be bigger than the third. And if I add 6 and 1.4, I get 7.4. So I have a guess what might have gone wrong if your mode isn't, is your mode in degrees?
Yeah.
Okay, and did you close all your parentheses?
Yeah.
Then I don't have a guess what went wrong. That's all I had. Yeah.
Okay, so find gamma, did you just do sine 35 over 6 equals, like, find gamma 1, just...
Gamma 1,
Yeah.
we did alpha plus beta 1 and subtracted from 180.
Oh, okay, yeah.
Because we already had those two.
Okay.
Same thing with gamma 2. Gamma 2 is wrong? Oh, 14.886. Okay. So that would throw our answer off a little bit. Thank you.
Why isn't it the other way around? Like, why wouldn't gamma 1 be...
Well, we couldn't find gamma 1 and 2 because this was empty right away.
Right,
So we had to do the betas first.
yeah.
And then once you have an alpha and a beta, just add them together and subtract that number from 180.
Yeah, so what gamma 1 be... Oh, wait, never mind, okay, I understand.
So you're adding what's in the two blue circles and subtracting from 180, and then the two green circles. So maybe let's check and see if do we have anything different for C1?
For C1, I got 10.41.
Okay. Again, I can't say if that's correct without a calculator, but I can say it seems reasonable because it's the biggest side. And if you add any two together, it's now bigger than the third. Did anyone else get 10.419? Okay, then if we got that, it's probably right. And now C2, okay, I'm looking at what's in green, 35, 130, and 14. That's the smallest angle. So it has to be the smallest side. So it's got to be smaller than 6. Okay? But it can't be too small because you have to be able to add it, A and C2, and it's got to be bigger than 8. So maybe 2 something, I'm just guessing. But yeah, Devin?
2.682.
2.682. Okay, based on what I said, that seems, it fits that criteria, so it seems reasonable. Okay. So, any questions on that one? Okay, so that's the hardest type. Okay, you're really solving two problems at the same time. And if you wanted, you could do two separate tables, but I think that gets confusing. Yeah.
On the test, if we were to answer it and it's off by like a decimal, will it still be wrong?
Yeah, if you're rounding to 3 decimal places, like 14.886, and you get 14.9, that would be okay. But if you get 15.9, that I would mark wrong. Because if you're going to 3 decimal places, you shouldn't be off in the whole number part that much. Okay? So if you had like 15 here and you showed your work, I'd probably give you credit for 15 because that's only off by like 0.12. That's not that much. But if you had like 16 or 17 here, that's off by too much. Yeah. Okay, so don't do any rounding till the very last step, just like we've been doing all along. Okay, anyone else that got something different that they're not sure why it came up that way? Okay, without looking at your calculator and seeing exactly what you typed in, it's hard for me to say why it went wrong. But I'd say the two biggest things are make sure you're in degrees and make sure you close your parentheses. And you type in the right numbers. Okay, so any question on that? Yeah.
For C2, I got 2.687,
So that's probably just the way things were rounded. That would be fine. Because you're within 5 thousandths of the right. So that's okay. Yeah. That's pretty close. All right, so let's, I want to show you just visually how you can take and keep two sides the same and an angle the same and end up with two different problems. Okay, so I'm just going to sketch it out very accurately. So I'm going to take this triangle, and the first thing I'm going to do is make a copy of that side. Does everybody agree that that side and that side are the same length? Okay, so they have a side that they share the same length. Okay, next thing I'm going to do is I'm going to take this side, make a copy of it, and I'm going to flip it. Okay, by reflecting it, is this side still the same length as that side? Yeah. So now I have a triangle with two sides that are the same length. And I'm going to take and draw my third side. Put it right there and then just shorten that a little bit. Okay, and I'm going to group this together and then I'm going to drag it up so you can see which angle I kept exactly the same. Okay, I kept that angle in the lower left exactly the same. So there's two different triangles that have two sides exactly the same length, an angle exactly the same measure, but they're different drawings. Okay, so what I just drew there is what just happened in the last problem. Okay? They gave you everything that I marked in the blue and the black. And then everything that you found had two answers. This was one answer. That was the second one. Not to scale, but that's the idea. Okay. So any question visually about how the two-solution case can happen? Okay. What I just did can't happen on any other case. Okay. It's not possible. All right, so let's, before we do the word problems, we'll finish up with this one. Okay, so again, how do I know that this is law of sines? You could always make a sketch if you're not sure, but you don't need to if you make this table. Okay, I have a full row. That tells me it's law of sines. What is the empty row that I can't solve for tell me? Yes, the empty row with it being impossible to find anything in that row right now tells me that it's the side-side angle. Okay, so I have to use row 3 because it's got everything in it, and I have to use row 1 because it has at least something in it, and that's the first thing I'm going to try to solve for. Okay. Any questions on why I have to get, or try to get alpha right away? Yep.
Because you can only have one letter in your proportion.
Yeah, you can only have one letter, and if you picked row 2, you'd have 2 letters. Yep. So if you pick the first row and the third row, you're going to have 3 numbers and then 1 letter. So we're going to find alpha. Okay, and we're going to set it up as sine of 50 over 1. Technically, if it's over 1, you don't even need to write over 1, because dividing by 1 doesn't change it. And then on the other side, Becky, what are we going to have on the other side? Yep, sine alpha over 2. Okay, and normally I would cross multiply, but I don't even need to do that much work. All I really need to do is double each side, and that gets sine alpha by itself. So I've got 2 sine 50. I'm not going to write divided by 1. which is 2 sine 50, equals sine alpha. Okay, and Emma, I've got sine alpha, but I want to get rid of sine. So what do I use to do that?
Take the inverse of sine.
Yep, I'm going to take inverse of sine on the left and on the right. And now we're going to type that in and see what we get. Okay, so if you have your calculator, try typing that in and tell me what happens when you type that in. You got an error? Okay, that's weird. You got an error too?
I also know.
Oh, you also got an error.
I also got
Well, maybe that's not weird then. So let me try to type it in. Yeah, I got an error too. So let's look at this number for a second. Okay, 2 sine 50. Let me just get rid of the first part. Roughly 1.5. So if you graph sine, okay, like we did last week, what's the highest that sine ever goes? 1. The number that we're plugging in right here is 1.5. So basically, the reason we got an error is because you're trying to figure out where this and this cross. Okay? Where do those two graphs that I just drew cross? They don't. That's why you got an error. Okay, they never cross, so there is no solution. That's just another way to think about it visually. Okay. So we get no solution for alpha. Now normally at this point, if we had alpha, we would now add it to gamma and subtract from 180. But since we don't have alpha, that means we can't find what? No? We can't get beta because we have nothing to add to gamma to add up to 180. And if you can't find beta, you can't find the side across from it. Okay, so that's a no solution. So what would happen if I try to draw this? Like if I actually measure everything out carefully like I did in the last problem? Yeah, it would be a triangle where the third side wouldn't connect. So I'm going to sketch it so you can see what happens. Okay? But any question on why it's no solution? Okay, and like I said yesterday, it's pretty much an all or nothing thing. If one part has no solution, everything is no solution. If one part has two answers, everything does. All right, so let's try to sketch that. Okay, so what I did earlier is I already drew out a 50-degree angle. Okay, I measured it exactly. I can just use this protractor to draw any angle that I want. So I drew a 50-degree angle. And I need a side that's 2 units long and a side that's 1 unit long. It doesn't matter if it's 2 inches, 2 feet, 2 centimeters. It just has to be 2 units and the other one is 1 unit. So that's going to represent 1 unit. And then I'll put 2 of those together. Okay, and this side is now 2 units. Okay, it's twice as long as the other side. Any question on that? So 2 units, 1 unit. All right. Actually, I want to group that together. Okay, now, the longer side is A. A is the side that's on the diagonal. I need to set that at a 50-degree angle, which just about like that. Okay, close enough. Okay, I can't change that. I have to keep that exactly at a 50-degree angle, because that's the angle. Now, C is the side that would be over here. Okay? It has to connect to the end of A. But they didn't tell me the angle, so I can turn that side however I want. And technically, I can only turn it if I group it with something. kind of weird. And then I can erase that. But now I can turn it, just the way it works. Okay. So I can put that right there, but I'm allowed to turn it however I want. Okay, so that's side C. Now B has to be horizontal. Okay. If B's not horizontal, then this angle wouldn't be 50. But they didn't tell me B. That's something I had to solve for. So B can be any length I want, but it has to stay horizontal. So is there any way that I'm ever going to be able to connect this top side and that bottom side? No. No matter how you try to turn it, it's never going to reach. I mean, you can shorten this, but you can't bring it up. You have to keep it horizontal. So no matter what you try to do, it's just never going to close and make a triangle. That's why there's no solution. Okay. Any questions on that? All right, so the last two problems we'll look at are going to be word problems. Okay, the most important thing in this problem is really going to be what we do after we read everything. So you can write everything down, but really we're going to do something with all the information that's written to make it easier. What do we generally do when you have a bunch of stuff that's written to make it easier to see the problem? We're going to do what?
We can either draw it out or write it down.
Yeah, we're going to draw it out. And when we draw it, the goal is to get a triangle somewhere. Okay? Okay, so what's going to happen here is we're going to measure the height of a mountain. Now, the mountain could be anything. It could be a building, it could be any object. We're just using a mountain. So to measure the height of a mountain, a surveyor is going to take two different sightings of the peak. Okay, so what's going to happen is the surveyor is going to stand in one spot, they're going to do something, then they're going to back up 900 meters, and they're going to do something, the same thing again. Okay, and I'll explain what they're going to do. Okay, when they take a sighting, what the surveyor is doing is measuring the angle to the top of the mountain from where they're standing. Okay, so if they had a device like a transit, usually there's some kind of laser on top of that, and they've got a sight, and they can sight the top of the mountain right in that laser, and they can figure out the angle from where they're standing that you'd have to look up at to be looking right at the top of the mountain. And finding that angle, that's the key to figuring out how tall the mountain is. Now, if you're looking at something at a certain angle, and you back up from that, what happens to the angle? If you're staring at an object and you stay staring at it, but you back away from it, the angle starts to decrease. You know, think of like if you're staring at a certain point on a movie screen. Right? If you're in the front row, you might be staring very, very steep up, but as you move back, the angle decreases. So when the surveyor backs up 900 meters, the second angle is 35 degrees. Okay, so if I was going to summarize this, basically I'd say two sightings, 900 meters apart. First sighting equals 47 degrees. Second sighting equals 35 degrees. That's all you really need to write down. And we're going to assume that the device the person's using to measure the angles is level with the ground. Okay, in reality, that wouldn't be true. Usually the device they use is on like a tripod, and it's like 5 feet or so off the ground. But assuming that the device they're using is level with the ground just makes it a little easier. Okay, so we want to find the height of the mountain. Let's find the height of the mountain. Okay, so we're going to draw a picture. What's something that's going to be very important to put in my picture? And I'm thinking like actual physical objects from the word problem. So don't say a triangle, because that's not, a triangle is just going to happen from the stuff you draw. Yep. Yeah, first thing we need is the ground. Okay, so we get the ground. What else do we need? Yeah, we need a mountain. Well, we need something that's, over here. The easiest way to represent the mountain really is just to draw it like as a vertical line. But if you want to really draw a mountain, there's your mountain. Okay, so get a mountain. And then two other things I need. Yeah? Yeah, you know? Yeah, what about the surveyor? What do we need to know about him? Where he's standing. We need to mark 2 spots. It doesn't really matter where you put him. But we do know the distance between the 2 spots. What's the distance between the 2 sightings? Yeah, 900 meters. Okay, and each time, and I'll put this in as a dotted line in a second, he's going to measure the angle right to the top of the mountain. Okay, from 2 different spots. And that dotted line represents kind of the laser from where the surveyor's standing, pointed right at the top of the mountain. Okay, the first time that the surveyor measures the angle, he gets 47 degrees. That's the angle from the ground that you'd have to point the laser at. The second time is 35. Okay, so our goal is to find this. That's the height of the mountain. Okay, and I'll put that in a different color. So I want to know the length of that line in red. How come this isn't the height of the mountain? Going up the side.
Because you can't see it.
Well, let's say, or this. How come that's not the height of the mountain? Yeah.
It's angled.
Yeah, it's angled. Think of it if it was like a pyramid. Going up the side, that's the slant height. The real height is if this was a pyramid and there was a hole in the top and you drop something straight down to the middle. How far does it drop? That's the height. Okay? We don't want the height going up the side. Okay, so first thing we want to look at is what we were given and see if there's anything else we know. And I want to start by focusing on this triangle in green. Okay, I can't really do much with that side in red because I don't know any sides in this triangle. Okay? But eventually, I want to do something with this triangle in blue. I just don't know any sides yet to be able to do anything with it. Okay, so we'll come back to that triangle in blue in a little bit. But anything else I can label about this triangle in green? Yeah, Gabe?
You can label the other angle.
Yeah, which other angle?
That one, the one on the bottom right.
Yeah, we can get the one in the bottom right. How do you get that?
Take 180 and subtract 47.
Yeah, so this angle is 133. And now we can actually do something else. What else could I do? Yep, Miles?
Get the top right angle of the bigger triangle.
Yeah, and how would you get that angle?
Add those 2 numbers at the bottom, just subtract that number.
Yeah, add up the 2 angles at the bottom, subtract from 180, and you're going to get 12. And the reason I wanted to get that 12 is because if you think about the law of sines, the whole key to that law is you have to know a side and the angle across from it. If you know an angle and you know what's across from it, you know an entire row in the law of sines formula. Without that angle, you don't have a row that's complete. Okay, so let's call this side x. I'm going to solve for this side that's x, which if you want to visualize it in the blue triangle, would be right there. So if I wanted to set up my law of sines, what could I put on the right-hand side? The sine of what? Okay.
12 degrees over 900.
Yep. We don't have anything labeled A, B, C, alpha, beta, gamma, so now it's important to just understand the idea. Sine of an angle, divide by what's across from it, equals sine of another angle, divided by what's across from that. So if you want to find x, what angle would you use?
35.
You would use the 35. Sine of an angle, divide by what's across from it, equals sine of an angle, divide by what's across from it. And then we can find x. Now, before we do it, is x the height of the mountain? No. It's not the height of the mountain, but it's a side in the triangle that will then tell me the height of the mountain. And it's going to be a special triangle because the side of the triangle that represents the height of the mountain, it's in a right triangle. So that's even easier than what we're doing right now. Okay, so x is going to be 900 sine 35 divided by sine 12. Okay, so I need to type that in and then round it off. Does anybody have that number? Just type it in. 900 sine 35 divided by sine 12. Okay, so I got about 2,482, let's just say 0.9. So 2,482.9. Okay, and I'm going to label that right here. Now, in that blue triangle, there is one other thing that I knew, and I didn't copy it down. What else do I know in that blue triangle? It was given to me originally. Yeah?
I would say the 47.
Yeah, we know this is 47. Okay, let's call this red line the height of the mountain. So now I've got 47, h, and the 2,482. What's the name of side h compared to the 47-degree angle? Yep.
Opposite.
It's opposite. And the other side that I know across from the 90 is the, well, h is opposite.
Adjacent.
No, adjacent would be the bottom. It's the hypotenuse because it's across from the 90. Now, what trig function involves opposite and hypotenuse? Sine. So from here, we're finishing this up like we did 2 weeks ago. If you want to use law of sines again on this, you could. But I think it's easier to just say sine of 47 equals opposite over hypotenuse. That's SOHCAHTOA, what we just did. Okay, and now to get the 2,482 on the other side, I would do what? About, who I haven't heard much from today? Wendy. What would I multiply? What would I do to get the thing on the other side? Yeah, multiply. So I'm just going to type it in. I'm not even going to write it. 2482.9 times the sine of 47. And that is the height of the mountain. 1,815.9 meters.
What did you just do?
What's that?
What did you just do?
What did I do? I just typed in 2,482.9 times the sine of 47. So we just want to get h by itself. Okay, so that problem's a little involved because you gotta find a side first in a triangle that's not even your answer, but you have to do it to get your final answer. Okay, you can't jump to finding h right away. It's not possible.
That top angle, we already know that, right? Like,
We could figure that out if you wanted it.
would you just take the, like, 12 degrees, like from the other diagram, and just subtract that from 180 to find 168?
This angle right here?
Yeah, like how you found the 133 angle before
Right, well, if you wanted that, what you do is add 47 and 90 and subtract from
Oh,
180.
yeah.
Yeah. That's how you get that one. But you don't need it. So if you don't, you could find it, but you don't need it. Okay, that would represent, yeah, it's just a different angle in the problem. It's kind of like the angle that you would be looking down at the surveyor. If you were standing on top of the mountain, you'd have to look down at him, and he's looking up at you. So. Okay, any other questions on that one?
What's the 900, was that given?
The 900 was given. That's the distance between the two sightings. Yep, that was given. Okay, any other questions on that one? Okay, so last one. So this one is going to be about a ship that's in the ocean, and the ship has a radio, but it doesn't have a GPS. The GPS broke. It's cloudy, so they can't see any stars. What else? It's nighttime, so they can't see any landmarks. So they don't know where they are. Everything's working against them. But they have a radio, so they can at least say that something's wrong, or everything's wrong. So when they radio in, okay, the Coast Guard station, there's 2 Coast Guard stations that hear them. Okay, we'll call them Z and X when we write them in the diagram. But the first one is Station Zulu. And Station Zulu can determine that the signal is coming from a certain direction. Right? So basically, if you send out a signal, let's say here's the beach, here's a couple Coast Guard stations, here's your boat. If you send out a signal, this station can determine the signal is coming that way. They can just say the boat is that way. But they don't know how far along this line the boat is. Okay, this station could only say the boat is somewhere along this line. But then if the other station can say that the boat is somewhere along that line, then there's a place where those 2 lines cross, and that's roughly where the boat, or where they should expect to look for the boat. Okay, so that's the idea. Okay, so now we'll set that up. The first thing we need to know is how far apart are these stations. Okay, that's something that would be known. Okay, how far apart on the coast are those 2 Coast Guard stations? They're 120 miles apart. And specifically, the way we're going to draw it, Zulu is going to be to the left of X-ray, because it's west, it's left. Okay, so a ship sends out a signal. You don't really need to write that, but that's important. Okay, the call to the first station comes in at a 40-degree angle. Okay, and I'll explain how you sketch 40 degrees east of north. I'll explain what that means. Okay, so 40 degrees east of north. That's the bearing, that's the direction of the first signal. Okay, the second station gets a signal, and the signal comes in 30 degrees west of north. So all you really need to do is write down second station equals 30 degrees west of north. You don't have to write the call to the station indicates and all that stuff. Okay, so second station is 30 degrees to the west of north. How far is each station from the ship? Yeah, that's what we want to figure out. How far is each station from the ship? So they're asking for 2 things this time, but in this problem, you're not going to have to make a second triangle. You're going to be able to do everything with just 1 triangle, unlike the last problem. All right, so this one, we definitely need a diagram, and it's pretty much going to look just like I drew right there. Okay, so I'm going to start with the coastline. Okay, just make it nice and simple. I'm going to put the 2 Coast Guard stations. One here, one here. How far apart are the 2 Coast Guard stations. 100, 120 miles. Okay, so this is 120 miles between the 2 stations. Now, the other thing I want to draw is they're giving me bearings, but the bearings are based off of north. Okay? North is up, if you want to draw it on paper, up and down. So if I'm going to draw a bearing from north, I need a line on my paper that represents north. I need it here, and I also need it over here. Now I've got something to measure off of. Those 2 lines represent exactly north. Okay, I'm going to name each one of these stations. So it says Zulu is to the west of X-ray. So that means this one is Zulu. It's to the west. This one is X-ray. Okay, and the boat is somewhere out there. I don't know really if it's closer to X-ray or closer to Zulu. I just put it somewhere out in the ocean. Okay. Any questions so far? Now I'm going to draw dotted lines that represent, kind of like in the last problem, I represented the laser. This is going to represent the radio signal. So this boat is going to call the first station. It's going to send out a signal. And it's going to send a signal to the second station. And just to try to make that clear, I'll draw them as dotted lines because that's the radio signal. Now, I know a little bit about the angles that the signal's coming in at, and that's what I have to go read. It said the call to station Zulu, okay, the one on the left, comes in at a bearing 40 degrees to the east of north. So if this is north, 40 degrees to the east. Okay, east is like you're going to the right. That's 40 degrees to the east of north. And that could be a little tricky to label if you're not sure what they mean. But any question on that? Now the next angle, this is also north. The next angle is to the west of north. Okay? And that angle is 30 degrees, you could almost say to the left of north. Okay? So 30 degrees to the west of north. And actually, I think the way I put the boat, that's actually accurate. That angle should be smaller because the boat is closer. So I just guessed. Okay. So basically, here's our triangle. The 2 dotted sides and the side that makes up the shoreline. Okay. Anything else I know inside that dotted triangle? I've got some angles outside it, but I really want to know the ones inside it. Okay.
Can't you find those 2 angles on the bottom?
Yeah, we can find both of those. What is this one on the left?
50.
Yep, that's 50. And the one on the right? 60. And we could also do the one at the top now, too. Why do you think I would want to know the one at the top? That angle is going to be very important. Because without it, we can't do anything. Because I know the side that's across from it. In order to use law of sines, I need to know an angle and the side across from it. So 50 and 60 adds up to 110. So what's that angle at the top? 70. Okay, so if you want, you could redraw this triangle without the boats and the Coast Guard stations. I'm just going to draw a triangle without all the extra stuff. Okay, so this bottom side is 120. That was 70, 50, and 60. Okay, and find A and B. A is the distance from the boat to station Zulu. B is the distance from the boat to X-ray. So now that we have the diagram, you can forget that it's a word problem. Just solve for those two sides. Okay, so let's set it up to find A. Okay, in my proportion, what could I put on the top for the left-hand side? Sine 60 over A. Yep, because we're finding A. And then what about on the right-hand side?
Sine 70
Perfect. Sine 70 over 120. We just type that in, and then we'll know the distance from the boat to A. So it's going to be 120 sine 60 divided by sine 70. Okay, I'll come back, or while we're doing B, if somebody types that in, or we already have it.
110.592.
So it's about 110.59.
592.
Okay, so we've got A. And now we'll find B. What side of this fraction am I going to use again to find B? Yeah.
Well, my question was, when you divide sine 60 on each side to get A by itself, why does,
Divides by sine 70.
oh, okay.
Yeah. You have to divide by sine 70.
Yeah, but if you're trying to get A by itself, wouldn't you try and divide by sine 60?
No, because you're going to have A times sine 70,
Okay.
and you want to undo that by moving the sine 70, so it's divided by sine 70. Yep. So yeah, I'm pretty sure that's what you want. Okay. And now what part of that are we going to reuse to find B? Yep.
You're going to use sine 70 over 120.
Yep. We're going to use that again. Except now, just pick the other angle and the other side. So sine 50 over B. Sine 50 over B. And just to go through the cross multiplying again carefully, it's going to be 120 sine 50 equals B sine 70. But then you're going to have to divide by sine 70 again. Okay, so we got 120 sine 50 over sine 70. And does anybody already have what that is?
97.824.
97.824. So I'm just going to say 82. So, practically speaking, why would we care about the distance between the boat and the Coast Guard station? What would that distance might be important for in making some kind of decision? Yeah.
Like if it should go to which station or we go or whatever.
Okay, if the boat has power and it's trying to get somewhere, now let's pretend this boat is just adrift. So then, why might they still want to know how far the boat is from each station? Yep.
So the Coast Guard can send some boats to help them? So
Yeah.
how far is it going to go?
So depending on how far it is, that might influence which station goes to rescue, or if they have enough resources, maybe both go. But they also have to take into account if maybe Station A has a helicopter and Station B only has a boat, well, A is going to be able to get there a lot faster, most likely with a helicopter. And what's the other thing I kind of assumed in this problem about the boat? Something that wouldn't happen in real life, but we assumed it here.
That it was staying still?
Yeah, that it was staying still. Okay, if it was in, let's say it was going to take the Coast Guard 5 hours to get to the boat. If the Coast Guard sent a helicopter to where the boat is now, 5 hours from now, the boat's not going to be there. Maybe the boat's going to be over here. So the Coast Guard has to go to where the boat will be in 5 hours, maybe based on the way the current is moving in and stuff like that. All right? So we kind of simplified it by assuming it stayed still. But it probably wouldn't be. Okay. So any questions on that one? All right, so that finishes up Okay, law of sines. So tomorrow we'll look at law of cosines. Okay, so the homework, same section as last night, 267. And we'll pick up with 29 to 35, just the odds, and 39 and 43.